Now I want to talk about simplifying rational expressions. Remember that if I give you a ratio, say P divided by Q, I can multiply it by 1 or by anything over itself and still have an equivalent ratio. So what I'm saying is that if I have P over Q times R over R, that's still the same thing because R over R is just equal to 1. If I give you 3 over X and multiply it by X squared over X squared, you can see that this would be the same thing as just 3 over X because X squared over X squared is equal to 1. But if we actually multiply this out, so this numerator would be 3x squared, and the denominator would be x times x squared, which would be x cubed. These are equivalent expressions, equivalent rational expressions. This one is simpler than that one. This one has extra factors of x squared on both top and bottom. That can be canceled out. So this would be the simplified form here. Another example would be something like this. If we had x squared minus 9 divided by x squared plus 6x plus 9, they want us to simplify this. And we can do that by noticing, let's notice that the numerator here is a difference of squares. We can factor this then immediately into x plus 3 and x minus 3, right? Because x squared, square root of that is x, minus 9, square root of that, square root of 9 is 3. So we have a difference of squares, and that's how that factors out. On the bottom, what are my two factors of 9 that add up to 6? How about 3 and 3? That means we can factor this into two binomials as such. But now, if I look at the factored form for each of these expressions in the numerator and the denominator, I see that both numerator and denominator have a factor of x minus 3. So that could be canceled out on top and bottom, which leaves me with just x minus 3 over x plus 3. This is a simplified form of this. They are equivalent to each other, but this is a simpler way of writing the same thing. The next thing I want to talk about is multiplying rational expressions. For example, say we have 3x over x squared plus 5x times 3x plus 15 over 6x. And I want you to multiply that out. The first thing that we're going to do here, step 1, is factor both top and bottom. Factor top and bottom. So this is going to become, well, the 3x here, that's already in its, like that can't be factored down. That's already in its factors of 3 and x. On the bottom, x squared plus 5x, is there anything we can pull out of both of those terms? And I would say yes, there's an x in both of those terms. So I'm going to pull that out. That leaves me with an x plus 5 here. Over here, is there anything that can be factored out of these two terms in the numerator of the second expression? And yes, I can pull a 3 out of both of those terms, and that leaves me with an x plus 5 up here. Down here, I have 6x that's already in its factored form. It can't be factored down any further. Step 2, I want to cancel out any common factors on top and bottom. Are there any common factors here on top and bottom? Well, yes, I see an x plus 5 here, and an x plus 5 here on top and bottom. That cancels out because x plus 5 over x plus 5 is just 1. And I see a factor of x up here and down here. That could be canceled out. If I multiply this out, I have just 3 times 3 up top over x times 6 on the bottom. And notice again, that can be simplified further. 6 is 2 times 3, and 9 is 3 times 3. So I'm going to cancel out that factor of 3, which leaves me with a 3 up here and a 2 down here. So this is 3 over 2x. So our third step there, let's see, our second step here was to cancel top and bottom, and our last step here is to multiply and simplify. Now you can do homework problems number 17, 19, 21, and 23. Some of them are more complicated than this with factoring, but it's the same basic idea. So I just want to say one last thing about dividing rational expressions. In the case of 3 over x, for example, divided by x minus 1 over 4, these are two rational expressions and they're asking us to divide them. What you want to do, remember, when you're dividing fractions is the same thing as multiplying by the reciprocal of that fraction. So we're just going to take one of them. It actually doesn't matter. It doesn't matter if you take the first one or the second one. I'm going to take the second one and take the reciprocal of it, which would be 4 over x minus 1, and multiply it by 3 over x. Same thing right here. These are equivalent expressions here. Then I can just multiply the numerators. 3 times 4 is 12, and multiply the denominators, x times x minus 1. And then I can distribute the x if I want and get x squared over x on the bottom.